Hello everyone and welcome to the informatics Zoom session for class 11. In this section of ours, which is our sixth session, we will be discussing further on the number systems. As you guys know, we have already discussed about what is a number system, what are the different types of number systems that exist in the world of computers. Moreover, we have also discussed about our conversion between the different number systems, that is, the conversion from binary to decimal and vice versa. Moreover, we also talked about how will we convert decimal numbers into octal numbers and vice versa. Today, we'll be further talking about how we will convert decimal numbers to hexadecimal numbers. After completing the conversion of decimal numbers, we'll move forward to the conversion to binary numbers. So we will discuss about octal to binary and hexadecimal to binary conversion. We will also discuss the ways to reconvert them back to octal and hexadecimal numbers. So without wasting any further moments, we will start with our topics. Let us relook at what we have already discussed about the four number systems. We have discussed the decimal number system is made up of 10 digits, starting from 0 up till 9. After this, the further digits are nothing but combination of the digits from 0 to 9. So if you assume that 0 is nothing but 0, 0, 1 is nothing but 1, 0, 1, and then we have 0, 2, then we will have 0, 3, 0, 4, 0, 5, 0, 6, 0, 7, 0, 8, and 0, 9. When all of the combinations of zeros at the first place and 1 at the 0th position has happened, then we will move forward with the combination of 1 at first place and then the other numbers at the 0th position. So now we'll move forward with 101112, and we all know how the decimal system number system works. After that, we will also look at the binary number systems. Binary to decimal conversion is pretty simple, and you can very easily say that each number over here can be multiplied with whatever uh, position element it has, and the position value should be kept uh, with base 2, and then you can add up the number multiplied with the element with the number at the position. We have already discussed this before in our previous video. The octal number system is made up of 8 numbers at the base number, or as the name octal suggests, 0 to 7. What happens after 7? The same thing that happened after 9. After 9, there were no new numbers, and hence we had to combine two numbers from here. Similarly, after 7, we do not have any new numbers. We cannot have a 8 in the octal number system. Hence, we will do nothing but combine 1 and 0 over here. And the system moves on until 1, 7. Because at 1, 7, we have combined, or we have done combination of 1 at the place 1 or position 1, and rest of the numbers at position 0. We will then move forward with number 2 at position 1, and then 2, 1, 2, 2, 2, 3, and so on. The hexadecimal number system gives us the largest possible numbers of state that a particular number system can have. So it gives us 16 options, 0 to F, where F represents 15 in the decimal number system. After F, again, the very same thought process works as after 9 happened in decimal number system. After F, you do not have any new numbers or any new symbols for the hexadecimal number system. Hence, you will have to now keep 1, 0, which is after 0, 1 is the smallest number. So 1, 0 comes at the next position. Let us look at our conversion. We'll first look at the decimal to hexadecimal conversion. Well, this can be easily done by successively dividing the number which needs to be converted, or the decimal number that needs to be converted into hexadecimal, by 16. Why 16? Because we want numbers from 0 to f to be in the remainder. As simple as it may sound, 16 when divided by 123 when divided by 16 will be divided 7 times, and we will have a remainder as 11. So we cannot write just 11 over here. The reason for this is 1 1 represents a altogether new state in terms of hexadecimal number system. But as we have already looked before, 11 is represented with the help of B. See, the number B of hexadecimal number system represents 11 of the decimal number system. As the remainder 11 is a decimal number, but we need our values to be shown in hexadecimal numbers. All we will do is just place B over here to make sure that the entire number system is in hexadecimal format. As simple as that. When you convert 123 with a base 10 into base 16, you will get 7B as your answer. Go and try yourself for 5 and 2 and n number of possible values which you may feel or which you may fancy. We will move forward for a conversion from hexadecimal back to decimal number system. Well, it is pretty much the same as it happened with octal and binary numbers. All we need to do is position the numbers in one format and then give each value a position number. So 7B, because B is at the least significant bit, it will have 0 position. 7 is 1 higher than B in terms of position, and hence its position number is 1. Multiplying 7, the number, into 16 raised to the power position and adding it with B, the number, into 16 raised to the power position, that is 0. This will give you 112 into 11 into 16 raised to the power 0. How did this 11 came? Again, the very same funda, that we need to have B converted into number. So, as you may see, 123 can easily be found out as our answer. This is the number from which we converted 7B. So the formula works, and this is a foolproof method to convert a hexadecimal number into decimal and decimal number into hexadecimal number. You should try a few more examples for your own will. We'll move forward to our next example of octal to binary conversion. Well, this table may be something similar to what you have already seen in the second slide, where we talked about all the 4 number systems. The only difference being that when you write numbers from 0 to 7, their binary equivalents can be written with the help of only 3 bits of numbers. You only need 3 bits of numbers to represent all the 8 different octal numbers. So 0 representing 000 and 7 representing 111. There are 8 different states from 0 to 7 over here. We will use this table when we are converting from numbers from octal to binary and from binary to octal. What you may always remember is that the octal number system has 8 numbers and can be represented easily with the help of just 3 bits. This number 3 will be very helpful in solving our questions. So a question may come that you should convert the number 704, which is an octal number, into a binary number. Well, what should we do? Just write the octal number 704 as 7, 0 and 4, and then convert each number over here into its binary value. Then regroup these numbers and then you will have your answer. For your convenience, I would suggest you to try for 4065. If you face any problems, just mail me on my email ID. When you reconvert some number back from binary to octal, it requires a bit of supervision or a bit of cautiousness. See, when you try and convert a number such as 111, 010, 011, 0. So when converting this number, what you need to do is you need to start making groups. And how many digits should we do or take when making a group? 3. Because we know that any of the octal numbers can be represented with a group of 3 numbers. So we'll start grouping from here. When we start grouping, the first group is of 110. The other group is of 100. Next we have 110 in our group, and then we are only left with this one, just one. But over here it is not making a group of 3. So what should we do? We will just prepend 00 before the 1. So 2 zeros before the 1 will help us create another group of 3. When we create this group, all the groups that we have made are now 3 digits, which makes our task very easy. All we now need to do is look at these numbers and convert these binary numbers back into their octal or decimal value, whichever way you think. Because again, all the numbers from 0 to 7 are equal to their decimal equivalents. Although the combination of 1646 is not a decimal number, 1646 individually can be taken as decimal numbers, but 1646 combination over here is an octal number. Hexadecimal to binary conversion. As we have thought, we will move ahead with hexadecimal to binary conversion, which is the last topic for this chapter. When we are talking about this conversion, there is a number missing over here. We have missed 0 before this. So 0 and 0000 should be prepended before 1 over here. So when making or doing the questions in your notebook, please be sure that you have prepended 0 at the top and 0000 over here. When you do this, you may notice that the number over here at the top position So you may notice that the number here at the top position or the last bit changes its value at every alternate position. The number at the position 1, this was position 0, now this comes position 1, changes its value after every after every two numbers. So 00, 11, 00, 11, 00, 11 and so on. The next number changes its values after every 4 positions, and the number to follow will change its value at every 8 positions. As you may notice a pattern over here, all you need to know is that this is just a temporary way, or as we say in our Indian language, a jugaad to remember this table. Over a period of time, you will, when you go through this table time and again, you will come to remember these, and moreover, you will be able to understand it very well, that how all these numbers came. So you may notice that the numbers from 0 to f can be represented using 0000 and 1111. When going for a conversion from hexadecimal to binary, we will again follow the same strategy as we followed from octal to binary conversion. The only difference being that now we will write each number, be it 0 or be it f, as a combination of four numbers. So when doing this or while writing each number as a combination of four digits of binary numbers, you will have to take again some precaution while reconverting it back to number. Again, you should also remember that a is nothing but 10 in terms of decimal number. When you write this down individually in terms of binary equivalent, on combining it, you will get the requisite binary number. You should try this for X09B for conversion of this particular number into binary format. Also, just let me know in case if you face any problems and we can always take it one-on-one. The next example and the last problem is to solve or to convert a binary number into a hexadecimal number. Understand the point that again we will start grouping from the least significant bit, that is LSB in short terms, or the acronyms for least significant bit is LSB. You must have heard this term time and again during your computer courses. So we will start from this 0 and we'll start making groups of 4. Why 4? Because we were able to represent, or it needed 4 bits to represent each and every number of the hexadecimal number system, which was unique. After that, say suppose after F, you may need even more bits because, or you may start increasing the bit size as and when required. So it is not like that when you are representing a 0, you will always need 4 bits to write down. But when doing conversion, you should always write it in the requisite number of bits. Say for an octal number, if you are doing the conversion from octal to binary, you should represent a 0 by 3 bits. Rather, if you are converting 0 in terms of hexadecimal to binary, you should represent that 0 in terms of 4 bits. This is just to maintain parity and has no other significance, because in other terms, a single 0 and 4 zeros are the same thing if you are just treating it as a simple 0. But to maintain parity over here and to get the requisite answers, we will have to do it this way. So binary to hexadecimal conversions can be achieved by doing the groupings from here. Again, as you may notice that 1 is again left and you do not have four number grouping over here. So we will append or prepend it by 2 zeros, reconverting back these to their original hexadecimal numbers. We will get 3A6 as our answer. Try this for another binary number and see what you may get as your fancy answer. Also try these conversions by converting binary into decimal and then decimal into hexadecimal. Try seeing if you are getting the very same answer, just to revalidate our concepts. So as you may have understood that there are alternate ways to conversion. This way of conversion of octal to binary and binary to octal, binary to hexadecimal and hexadecimal to binary is just another way of, or is just a way of doing things in a shorter manner. You can always do this by converting an octal number into decimal and decimal into binary, and then the binary number into decimal and back the decimal number into octal. So there can be a larger way and there can be this shorter way. You can do it with either way you wish you to do this one. If you have any questions, please let me know on my email ID. Thank you so much, everyone. Have a nice day.